Hi, good day everyone. My name is Wendy A. Lusutan under the Group 2. I selected the topic which is Lewis dot symbols, ionic and covalent compounds. This topic is our 9th lesson in Chemistry 16. So today, I'm going to flashback this topic based on what I have learned and what I have understand in this lesson. So let's start. For Lewis dot symbols, an element symbols with dot for each valence electrons. Valence electrons is an outer shell electrons in order to form or shared pair. For example, in that table for Lewis symbols. In group A, there's element lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. For electron configuration, for lithium has 2s to the power of 1. So that's how we get the electron configuration. So based on periodic table, as you can see in your periodic table, here's the lithium. So here's the electron configuration. Lithium has 2s to the power of 1. The same in beryllium has 2s to the power of 2. So according to Lewis symbols, here's his symbols. So Li maganda ay isa ka dot kani ing ana ang kay Lewis symbols. And for the octet rule, atoms lost, gain, or share electrons until they are surrounded with 8 valence electrons. Take note, number of valence electrons is equal of group number. Atoms aim to have the same electron configuration with that of noble gases, except helium. When we say noble gases, any of 7 chemicals that make up group of the periodic table. Example, the elements are helium, neon, argon, krypton, and xenon, radon, and oganesson. So that's the noble gases. For ionic bonding, transfer of electrons between a metal and non-metal. Take note again. Transfer electrons between a metal and non-metal. So that's the ionic. For energetics of ionic bonding, from the electrostatic attraction between a cation and anion. As you can see, here's a color red, blue, black. So, for black, lines show attractive forces between first nearest neighbors. Red lines show repulsive forces with second nearest neighbors. For blue, lines show attractive for third nearest neighbors. Fourth nearest neighbor interactions and higher are not indicated in the figure. So, move to lattice energy. Energy needed to completely separate a mole of solid ionic compound into its gaseous ions governed by Coulomb's law. So, here's formula. As charge of ions increases, lattice energy increases. Take note, if the ions increases, the lattice energy increases again. Ionic compounds, ionic are cracked due to electrostatic forces. For ionic compounds, current flows when electrons can move. For solid ionic compound, with high melting and boiling points. For molten ionic compound, liquid means it exists as a liquid in room temperature. For ionic compound dissolved in water, the ions are attracted to the water molecules, each of which carries a polar charge. For covalent bonding, sharing of electrons between non-metals. So, covalent na kita. So, electrostatic interactions, attractions between electrons and nuclei. Repulsions between electrons, repulsions between nuclei. Take note again, the covalent electrons between non-metals. Di ba, gaina is ionic compound or ionic bonding. Ang ionic bonding is between metal and non-metal. And this covalent bonding between both non-metals. So for Lewis structures, representation of molecules showing all electrons bonding and non-bonding covalent. So, That's all. Thank you. I hope you like this video and keep safe everyone, and thank you. Bye bye.